streamed talk of the day. We're starting to transition to birds of a feather sessions. So what that means is our team of speakers here, folks from Wiz, Alon and Amitai, are going to kind of give us a brief intro to what they've built, this community cloud database. And then the stream ends. So for those of you watching, hope you've enjoyed your day. What we'll do then is we'll kind of start a discussion. And what I hope happens, what happened last year, is that it won't be a bunch of people staring forward, but maybe we'll sit down, we'll turn around some of these chairs at the front of the room, and we'll kind of talk about what would make the community cloud vuln database more useful. How can we apply it to processes? How can we connect it to some of the things we heard earlier today? So the goal for these talks is not to be one-sided after the first 10 minutes or so, but to really start to apply the work that we've seen and create something together. So with that, please welcome Alon Amitai.
Thank you. So really happy to be here in this warm atmosphere that we have in this conference. So today, we are excited. We've been looking forward to this conference for a long time. My name is Alon. I'm leading the data and threat research team at Wiz. And with me is Amitai.
Hi, I'm Amitai. I'm a threat researcher on Alon's team. I'm also happy to be here.
Yeah, so we've been working together in the past, and we reunited at Wiz a few months ago, and I'm really grateful for that. So today, we want to, before we start the discussion, we want to have to make sure that we have some kind of a common ground, so the discussion is more fruitful, and that we, make sure that we are all on the same page. So we'll start with kind of a really brief description of the cloud vulnerability problem. Then we will walk through the story of CloudVulnDB, the database that we built with the help of the community. Then we'll show some examples. So the database in its new form is in air for the last month, and we try to show and collect few examples to demonstrate why is it good for and how it can be used by the community and by cloud customers. And then we'll finish with our last section. What's next? The discussion. We have some discussion points that we believe that are important, that should be the next steps of this community project. But of course, if they're we would like to hear your opinion and what do you think? What are the most important goals of the community cloud vulnerability database? Okay.
So before we talk about the database, let's talk about what we mean when we talk about cloud vulnerabilities. So basically, we mean either bugs in backend or control plane code, which usually don't get CVEs, bugs in middleware, which sometimes do get CVEs, and default misconfigurations, by which we mean that the configuration that the vendor gives that is built into the product has a security vulnerability and has to be fixed. We don't mean by this vulnerabilities in customer-installed software that tenants bring with them to the cloud, or non-default misconfigurations, as in errors that customers cause in their own configurations. So this is the cloud shared responsibility model that we all know and love, where the vendor is responsible for certain components, the customer is responsible for certain components, such as data and configurations. The problem is that there's an emerging new middle zone, which basically means that this model has a bunch of cracks, and it's sort of turning into more of a spectrum, where there's sort of a middle ground where it's not really entirely sure who's in charge. And this just also happens to be the area where a lot of cloud vulnerabilities have been discovered in recent years. And most of them didn't really have a straightforward remediation process, which is a problem. For example, when we talk about default misconfigurations, even if the vendor releases a fix, oftentimes it's the tenant's responsibility to either redeploy their resources or manually fix the policies. Middleware suffers from the same issue, as was spoken about by Nir and Rotem in their talk earlier today.
Okay, so let's start now with an example. We chose just one for just to show what are we talking about. So ChaosDB, it was a vulnerability that with the research found last August. And now for us it was fundamental for understanding the issues with cloud vulnerabilities. So I mean, when we worked on the disclosure process of this vulnerability, we understood that there are many gaps in the way that CSPs handle vulnerabilities. So in this case, so CosmosDB is a very popular database service for Azure, and we found a cross-tenant vulnerability. What it means, essentially, customer keys were exposed. Anyone could have accessed them and then use them to access other customer data and for read-write operations. And I mean, we won't get into details. We have, like in blogs, and we have other, I mean, you can see on YouTube the talk on Black Hat. We won't get into details, but what we want to, the most important thing here is that, so you saw Amitai's diagram, and in this case, the remediation should have been, like it had two parts. One by Microsoft, where they had to change the vulnerable configuration and the vulnerabilities on their side. But since keys were exposed, the customers had to rotate these keys, because you can't know. I mean, Microsoft said that they don't know of any malicious access, but regardless of that, the recommendation was rotate the keys. Initially, there was no publication. Microsoft didn't publish it. They just sent some notification through the health service that they have. And we told them that, I mean, it's a critical vulnerability. I mean, data could have been accessed by malicious attackers. People won't know about it. I mean, I know that at Wiz, we are also like cloud customers, and these alerts, like the service health alerts, it gets to the DevOps team, not to the security team. I mean, you get, like, it's the same place where you are getting alerts, like about, I don't know, downtime of specific services. It's not like where security alerts should be located, and eventually they published an advisory, but we noticed that there are some really fundamental gaps there. So one of them, there's no tracking system. So they just published a blog, and you saw the title of the blog. It was like update on vulnerability in Azure Cosmos DB Jupyter Notebook feature. And this is not a way, I mean, if you want to track the issue, understand how to do it, you can't refer to it just by this title. It's, I mean, you need to have some a better way and to publish it in a place, not in this health system or not through email. I mean, because things get lost there. Then severity. So there's still no severity model for cloud vulnerabilities. If I now have to fix ChaosDB, but I have to fix it now, but I have some other security issues. How can I prioritize them? And if I'm also an AWS or GCP customer and I have some other security issues there, how can I prioritize which issue should I remediate first? The enumeration, I discussed that, and also transparency. I mean, I think even until today, so since there are no versions for most of the cloud services and things change just in the backend side, you don't know when an issue is introduced, and you don't know like the exploitability time. So in the data is still, I mean, Microsoft didn't publish until today like the exact details of when the exactly when the exploit, when attackers could have exploited the vulnerability. So this is these are like 4 issues that we noticed, and there are additional 4 that we see that again there is no like standard notification system across all CSPs. I mean, like the CVE system of NVD, you can't. There's no one place where you can just go and see all the issues. It should be public place. And with cloud vulnerabilities, remediation steps and detections are usually more complicated than with software. It's not just the version, it's not just update the software version. It's, sometimes like ChaosDB. In ChaosDB, you had to check whether the keys were regenerated before a specific date to know if you are vulnerable. This is not something that is like easy or immediate to do, and we think that, we can do better, and we should do better.
So basically, cloud customers are faced with a very frustrating reality. So if I am a cloud customer, I don't really have any easy way to know at any given time, has a new vulnerability been discovered? And I also don't really have any way to know if a new vulnerability hasn't been discovered. At any point in time, a new vulnerability could be out there, and I have no way to know, like, if I look at this screen and nothing's on it, then I'm okay. There's no way to know if it affects a service I use or not. There's no way to know if my own environment is affected or not. No easy way to know during what time frame this vulnerability was actually in existence, right? Like since when until when, because there's no versioning. There's no way to know easily if it's been automatically fixed or not. Maybe it has, but not in my own environment. There's no way to easily know which of my resources are vulnerable to this vulnerability. And there's no really easy way to know how bad it is. Like, should I prioritize this ahead of something else? Should I be losing sleep over this? Due to the lack of a severity model. And finally, there's often no really easy way to know how can I fix it myself. Like oftentimes the remediation steps are somewhat vague or not useful enough or they're too generic for what I actually need. The practical consequence and why all this matters is that customers often remain vulnerable for a very long period of time. They often don't even know that they're vulnerable or that they need to take any action to fix what's wrong with their environments.
Okay, so as I told you, we started like understanding the scope of this issue last summer, a year ago. But there are some people who have noticed that before. So the CSA, they have blogs since 2018 that discuss the issue. There was another project called CloudEdge that is not is not live anymore. But they used to document some internet outages and cloud services outages and also vulnerabilities at some point. But and there are also some discussions in Slack channels. But for us, when we saw this is Shir and Ami, they had a talk on Black Hat last year about confused deputy vulnerabilities, and that also suffer from the same issues that we discussed. And we said, like on the slide over there, that it's time for a central CloudCVE database. So we started a Slack group on August, and you can see it. And I think there are many members of this group who are here in the conference, and we started having discussions about like the issue, and it helped us understand different views, different opinions about the issues, and how it can be better, like what should be the next steps. On November 21, so Shir and we had a talk on Black Hat Europe, and we also covered the security. We said that there's a call to action, and we need this cloud vulnerability database, and we characterize how this database should look like. Now, usually, I'm not a big fan of conference talks. I don't know if they have any immediate action, if people really, react and do anything because of these talks. But we were lucky that because we published a blog after this talk. And Scott Piper read this blog, and immediately, you can see his tweet over here. He just created a new GitHub repository and started listing all these cloud vulnerability issues. And it was critical, I think, in my opinion, that Scott had this immediate action, because sometimes we have big plans, but just being pragmatic and just starting something is the best way to start. So I want a round of applause to Scott for that. And a few months later, we partnered with Scott because we thought that it's a great idea, and we wanted to take this GitHub repository to the next step. And we launched the website, the Open Cloud Vulnerability and Security Issue database in June. And what we did is actually taking all the issues and vulnerabilities that were in Scott repository. We converted them to a new YAML format that I'll show later. And now the YAML format is kind of a structured way to analyze these vulnerabilities. And today, everyone can add a YAML, like a vulnerability, in a YAML format to the database. And as soon as it is approved and we merge the branch, it appears in our website. So it's something that, again, the community, now everyone in the community, when they find a new vulnerability, they can add it to the website and share the information with everyone. And I want also to thank all the contributors. These are both contributors of Scott's original repository and the new repository. So in the end, they are the ones that did the work and this documentation work. And also in the past month, we've added, or in the launch, we've added 30 additional issues. Some of them are after some archaeology work that we've done, and some of them are new. And actually, in the past month, we had 5 different contributors added issues to the database. So this is how an issue in the database looks like today, and there's also a search functionality, and it's something that should be easier to consume by cloud users, cloud researchers, and we'll discuss it later. And for us, this is, I think, the most critical part. Now we have this kind of a format that is can be used by anyone. And this is kind of a recipe to understand how cloud vulnerabilities should be analyzed. And we feel like there are differences from how CVEs, how software vulnerabilities are analyzed. And for example, there is the exploitability time instead of version detection method that is usually not really clear which platforms are affected, which services are affected, and we'll show a few examples of how this structured data can be used later.
So to talk a bit about how we think this actually helps solve the problem that we mentioned before. So whether or not we end up enumerating cloud vulnerabilities, whether or not they end up getting CVEs, there isn't really much consensus about whether that's the right way forward. We think it is. We can probably agree that building a knowledge base about them is important. We don't think of Cloud VulnDB as a solution to all the problems we mentioned. We do think it's a stepping stone in the right direction. We want to organize all the technical details and all the detection and remediation guidance about each vulnerability that's publicly known. Once we have all that information in one place, it becomes a lot easier to highlight the gaps. We can basically say, this is everything that humanity knows about these cloud vulnerabilities, and if there's a gap in the information on the website, we should feel free to go to the CSP and say, listen, you have a problem here, there's not enough information about this vulnerability, which is actually what we do when we do vulnerability assessment. We talk to the CSPs whenever there's a new vulnerability, we say, there's not enough information here, you need to be more transparent, here's a list of questions we'd like you to answer, and the YAML format can serve as a good tool in doing that. We also hope that the website sort of proves the utility of a CVDB as a security tool. We also hope that it shows the value of eventually enumerating vulnerabilities, and we also think that it can support new, novel, and creative security research avenues in an easier way. For example, we can do a sort of meta-analysis of all the vulnerabilities in the database. We can identify new attack surfaces of most concern based on places that have the most vulnerabilities. We can characterize new sort of cloud-native bug classes based on pattern recognition that we see in similar issues. We can inform vulnerability research, make sure that as a community our research efforts are pointed in the right direction in the areas that need it most. We can determine how efficient each type of mitigation is. This would require a lot of cooperation with the CSPs. They need to be more forthcoming about the exact type of mitigation they have in place in each service, or at least reveal a bit more information than they do now. But that's another value of having all this information in one place. And finally, we can perform variant analysis. This is something that we've actually taken inspiration from Maddie Stone at Project Zero, who at the recent FIRST conference spoke about how at least 50% of vulnerabilities discovered in the wild is then being used by threat actors before they were discovered by the vendors, were actually variants, meaning that threat actors are doing patch diffing. They're learning about vulnerabilities, and they're searching for vulnerabilities in similar products. For example, if they're open source, maybe go upstream, go downstream. You'll find a bunch of other vulnerabilities in the same place in a different product. So this clearly shows that sophisticated threat actors are doing this sort of research. We should be doing it as well, and we should be enabling it and making it easier. So just for a few examples, if we use the search on the website, it makes it a lot easier to recognize these patterns. Like this is an example of a Cloud Shell bug discovered by Felix Wilhelm about 2 years apart. It's basically the exact same bug in 2 different services, and it becomes very, very clear that this problem exists once you look at it on the website. Here's another example looking for Jupyter CSRF. We can see the same bug about 1.5 years apart in 2 different services. This was actually originally discovered by, this similarity was pointed out by David Bryant on the CloudCVE Slack that Alon mentioned before. And the practical consequence of this is that there was about 1.5 years where AI Hub had a Jupyter bug. If any threat actor out there was paying enough attention, they might have been able to discover this vulnerability in the other versions of Jupyter, in any other implementation out there. And this can be avoidable, especially if we do better pattern recognition and have better documentation of all these issues. And looking a bit towards the future, one of the things we noticed in the ExtraReplica research mentioned earlier today was that the bug was caused by a modification in the implementation by Azure. So this begs the question, could other vendors' modifications be similarly vulnerable? And if so, what's the best way to mitigate them? And this is something that Nir and Shir are going to be talking about at Black Hat.
Okay. And another way that the database can be utilized is really like for more quantitative analysis. So I created this kind of word cloud from the most prevalent words on this database. And here I think there are no real surprises. And now when we do the analysis, it's I think that we have some disclaimers. So we have the database, but it's important to remember that it's only, we can claim that we have all the information about cloud vulnerabilities that we know of, because sometimes there are issues that we don't really know about. Sometimes issues are just fixed on the CSP side and they are never published, and we can't document them because we don't know about them. Some services are older than others, so it's an issue to it's difficult to understand. If the fact that they have more vulnerabilities is because of their longer history. So we created this Jupyter notebook, and we'll also upload it to the GitHub repository. And what we saw, so this is kind of a figure of the findings over time, and you can see how it's actually interesting that we have this sign function, and you can see which vulnerabilities that, when vulnerabilities are found. We can also see which CSPs has the most vulnerabilities. But here it's also important to remember that, some CSPs are older than others. And when we do the breakdown according to severities, you see that actually AWS, many issues are from lower severity. And you have for Azure more critical issues. And this is something that Corey Quinn actually mentioned last week in a blog post, and really used their database as a reference to analyze security issues in Azure. And the last point is which services are the most affected ones. And the most interesting point here is that you see that most of the database and most of the services here are data services. So you have database for PostgreSQL, S3, RDS, Dataproc, Dataflow, and many other services.
So if we look towards the future, what our main goals we think that we should set, and this is something we'd like to talk about with you. We think the first thing we should focus on is implementing a uniform severity model. That should be the first order of business. We should focus on figuring out what parameters we need to be asking questions about for each vulnerability that comes along. We don't think CVSS in its current form at least is up to this task. There are a few possibilities. We've laid them out here. We could either use CVSS and sort of expand on it, or we could do something else. And we've actually been in conversation with Christoph Paracel, who developed the piercing index, which is basically, for those not familiar, it's basically a list of multiple choice questions that you ask about vulnerabilities, and you end up getting a sort of score, and it's very sort of cloud oriented. So this is something that we think is very important, and we're talking with him about what the best thing to implement in the website should be. But what's the end game? I think the end game is that CSPs should enumerate both software and service vulnerabilities. There should be much greater transparency. There should be more details released about every vulnerability by the CSPs. They should give exact timeframes of when the vulnerability was in effect, what the root cause was, which is something that it's very lacking nowadays. And exactly what the fixes that they applied in order to fix the vulnerability. And there should be very clear notification and tracking for every single customer, whether they were affected or not. But the problem is that we can talk about the CVDB as much as we want. At the end of the day, what we need to do as cloud customers, and we're also cloud customers, we need to demand greater CSP transparency. So we should make the CVDB as good as it can be and as useful as it can be, but we also need to raise our expectations and raise the bar when talking to CSPs and tell them, you need to be much more transparent about the information you release about vulnerabilities, so that we, as cloud customers, can make sure that we're making the best decisions possible at any given point.
Okay. So now I think it's a good time to start the discussion, and we have some points that. Okay. Some discussion points. So how Aaron, how would you like to, or we can do it? Okay. So these are some points for discussion that we prepared. So one is additional questions that the CVDB should allow us to answer. Also about how important is the severity model and how do you think it should look like, because for us it's something that looks like the next goal. And also how does cloud vulnerability assessment process looks for you, for cloud users? How do you do it today? How the CVDB can help you? And we can start with that. We probably you have more points, so we can start the discussion.